Welcome to this series of instruction on the new methods for contaminated runway surface condition reporting and the associated guidelines for takeoff and landing performance. The goals of this training will be to introduce the background knowledge needed to understand the principle behind these new guidelines, explain the history behind why the guidance was changed, and provide an in-depth look at the guidance itself.
The Runway Condition Assessment Matrix, or RCAM training, will cover guidance provided in the advisory circulars and notices issued by the Federal Aviation Administration. While some personnel in this industry may only be concerned with the specific guidance written for them, it is important for everyone involved in commercial air transport to know a little bit about all the relevant publications. This will give them a good understanding of how to assess runway conditions effectively using the RCAM.
In 1982, a DC-10 overran the runway at Boston Logan International Airport during winter contaminated conditions. In 1983, the National Transportation Safety Board found that there were fundamental issues regarding how runway conditions could be effectively measured, correlated to airplane performance, and communicated to the flight crews. In 2005, a Boeing 737 overran the runway at Chicago Midway Airport while also landing on contaminated runway during winter conditions. The resulting investigation revealed that the concerns raised in 1983 by the NTSB were still present and that a major review of industry regulations, policies, and procedures was necessary. In February 2007, the FAA convened the Takeoff and Landing Performance Assessment Aviation Rulemaking Committee, otherwise known as the TALPA ARC. After nearly 2 years of hard effort, a unanimous consensus emerged from the ARC participants. The result was the definitions, methods, and procedures we will be discussing today. The principles of this new system, which we will be discussing, are anticipated to form the basis of future ICAO guidance for contaminated runway reporting and operations.
The team of instructors you will be seeing were all involved in the creation of these new guidelines, in addition to having unique backgrounds in the subjects they will be speaking about. Jerry Ostronic is retired from a long career in the FAA and was the project lead for the efforts that created these guidelines.
Paul Sitsko directs airport operations at the Minneapolis-St. Paul Airport. He has extensive experience in winter operations and understands the importance of integrated operations with the FAA and the airlines.
John Godzinski is a captain on the Boeing 737 family of aircraft. He has extensive experience in accident investigations and aviation safety.
This team took the initiative and conducted a detailed task analysis to identify the tasks and the learning outcomes for each stakeholder involved in these procedures. The learning outcomes were determined using several criteria, beginning with tasks that required declarative knowledge at a basic recall level, such as knowing the assumptions surrounding data for takeoff and landing, to handling tasks that required procedural knowledge, such as knowing how to assess non-normal conditions. At an advanced level, these learning outcomes were mapped to cognitive, execution, and affective skill levels, such as assessing go-no-go criteria, detecting errors or irregularities in condition reporting, and making decisions regarding acceptable touchdown points. This team also broke down each operation into phases and studied the specific tasking required, mapping each task to specific learning outcomes, cues, and measures. Finally, an operational risk assessment was accomplished and a level of criticality determined for each phase so that an appropriate level of training could be established. Based on the tasks and the learning outcomes determined, the team did a KSA analysis to identify the knowledge, skills, and abilities required by each stakeholder to accomplish the tasks. This initiative was a crucial step in laying the foundations for the development of the RCAM training course.
Myself and the other leadership of the TALPA ARC decided if we're going to do this, let's do it right.
The new runway surface condition reporting terminology, procedures, and reporting criteria was codified in what has become known as the Runway Condition Assessment Matrix, or RCAM.
We argued about periods and singular words and phrasing, so that every single word and every single process in the RCAM is there because it means something.
While each aircraft might vary in how it behaved in each condition, it was possible to group all aircraft to one range of performance or another. To facilitate a more international standard, these performance levels were mapped to existing ICAO codes, presently in use for runway condition reporting.
There was a tremendous amount of discussion within the ARC what role friction measurements should play in determining runway condition reports. Some argued that it should be deleted entirely, while others argued that it should play a significant role. In the final recommendation, it was decided that airport operators should continue to use friction measurements as one of the tools in their toolbox to determine the effectiveness of the runway treatment.
With all the requirements and recommendations in place, there was an obvious need to train the airline personnel on the new methods and guidelines for takeoff and landing performance. To begin with, the target audience for the training was identified as FAA inspectors, military personnel, airlines, airports, and air traffic control personnel. The next step was to design and develop an engaging and immersive learning experience that was based on sound instructional design principles and methodologies. The RCAM training course uses real-life scenarios to make the content relevant and meaningful for the learners. The course uses accurate, highly detailed visuals and diagrams to set the tone, communicate key concepts, and engage the learners in their learning process. There are interactivities such as drag-and-drop interactions, clickable menus, branching scenarios, and simulations in the course to enhance learner participation. In addition to these, there are interactive exercises in the course that will provide learners with an opportunity to make decisions without taking real risks. The RCAM training course includes both formative and summative assessments. As part of the formative assessment conducted during the training, the learners are presented with questions at knowledge and comprehension levels. They are provided feedback to help them identify their strengths and areas for improvement as they are progressing through the course. As part of the summative assessment conducted at the end of the course, the learners are presented with advanced scenario-based questions that will help them determine whether or not the learner has reached the desired proficiency to use and apply the new takeoff and landing performance methods and guidelines. The aim of using different types of assessments is to not only boost learner engagement, but also to help them use and apply their learning to think and evaluate the outcomes of the decisions they make. The RCAM training course uses a responsive design approach that enables using one single version of the course to work on a variety of different devices, different browsers, and different platforms. The subject matter experts offer unique insights into training that cannot be garnered from reading the published material alone.
I think it's important for those who are not part of the TELP ARC to understand what a broad scope of industry input that was represented in the TELP ARC.
From aircraft manufacturers, air carriers, the National Business Jet Association folks, NBAA, FAA, airport operators.
What was amazing about the RCAM and the TELP ARC in general was how much intensive and very intensive science and effort went in by everybody.
But when airport operators sat down with performance engineers and aircraft designers engineers, and they were able to convince me that it's the depth of the contaminant, not the type of contaminant, that has resistance against the airplane. That was a real eye-opener. I would have never have thought that after driving my entire life through the Minnesota winters.
So this assessment criteria, assessment recommendation, is a whole new, I don't want to say requirement because it's not regulation, but it's a whole new best practice that it's almost not understandable why that did not exist before.
If I have an understanding of the RCAM, if the air traffic controllers have an understanding of what a code 5 means, a code 3 means, that will very quickly let somebody know, yes, it's safe to land here, or no, it's not safe to land here at this time. If everybody understands how this process works, it's only going to be better.
The RCAM training course, designed and built by experts in aviation safety and human factors, will have a significant impact on mitigating the risks associated with the normal slips, lapses, misunderstandings, and errors that can occur during daily operations. The training will allow the stakeholders to collaborate and share best practices related to runway safety procedures. This will not only benefit them, but will also bring consistency in implementing takeoff and landing performance methods and guidelines across the airline industry. The RCAM training course is an affordable solution that can be easily distributed worldwide to train airlines, airports, air traffic controllers, military, and regulators on the new methods and guidelines for takeoff and landing performance. With its unique training approach, the RCAM training course will assist in effectively employing the new guidance throughout the national airspace system to create an environment where the required level of safety can be achieved.